For centuries, the only way we learned about the universe was by observing light. Galileo made the first telescope. The humans have been looking at night sky for centuries. But it's only in 2015, after decades of effort, that we were finally able to hear the sounds that universe makes on the fabric of space-time. This sounds interacts with us almost every few minutes, coming from different parts of the cosmos. They go through our body and impact everything around us. This is the most fundamental way that we would learn about what is the structure of the universe at its largest stage, what happened to the universe right after its birth, what happens to the black holes that are being created every time when a star dies, or the centers of galaxies. Detecting gravitational waves was a multi-generational effort, and it took dedicated funding from the National Science Foundation for decades to make sure we create these experiments. These are large-scale experiments that are 16 square kilometers in setup, and those kind of experiments that got funded eventually allowed us to measure gravitational waves. This is not something that we can just build in a small lab and be able to detect gravitational waves coming from it. It does require a very dedicated federal funding strategy. This was one of the biggest scientific breakthroughs of the 21st century. You can almost put detection of gravitational waves in the same category as landing on the moon. This kind of feat happens only when science is a national priority to be advocated.
What would the scenario look like if we were trying to get funding from, a private funder or something like that, right? The kind of research that we do is, somewhat high risk, right? There is a possibility that we won't necessarily get results that we understand, right? The federal bandwidth for risk is a lot higher than a market is, right? And the product that we're creating isn't something meant for a market. It's meant for hopefully improving our society, right? We're looking for solutions to climate change by trying to tap into this, largely untapped resource of human environment data, millennia of human environment data that's in the archaeological record, right? So we're trying to do something that's not really a product that we can sell on a market, but it should contribute to, advancing our solutions towards climate change.
Algebra as a part of mathematics is very abstract, and people learn something about it in high school, because that mathematics is hundreds and even thousands of years old. But modern algebra has only been developed in recent years by researchers like me, funded like me by NSF. And some of the mathematics that they developed turned out to be useful, although they didn't expect it to be, namely in the design of algorithms for encrypting information. That's called cryptography. And every time you use your phone, or every time you deposit something in the bank, everything is encrypted. And this could only be done by the algorithms based on very modern mathematics, not known to people 100 years ago. So if this had not been developed, you would not have encryption, and you wouldn't be able to send money to your bank on the phone safely.
Most questions in physics are long-term, that require several generations of students and early career scientists to be trained over the time. For example, my students would be going to the experiments that have been funded by the National Science Foundation since 90s, and they get trained 30 years later on those facilities. That kind of continuation is fundamental to solve the grand problems that we are facing in the field of physics. Not having that kind of a certainty affects how we train the next generation of students, but also impacts our ability to answer questions that are civilization changing. That is the kind of direct impact it has if we don't have a support from the federal government.
Mathematics is a growing body of knowledge. As I said, in 1960, my whole area didn't exist. Now there are tens of thousands of papers and many, many books. Without funding me and my colleagues around the world, particularly in the US, a lot of this research would not have been done or couldn't have been done. So it's critical.